there guys, how's it going? This is Mike coming back at you with yet another video on number theory. In the previous video, we introduced Euler's phi function or phi function, which is for some given positive whole number n. It is the number of positive integers that are less than n and relatively prime to n. And we saw formulas that we can use to find phi of n for any positive integer n whatsoever. In this video, I want to talk about the theorem that we use in number theory as well as abstract algebra that pertains to this particular function. And kicking it right off, what that theorem is appropriately called Euler's theorem. And as I said, a very important result, has a lot of use in theory of congruences, as well as other areas in the world of number theory. Those areas are not some things that we're necessarily going to cover in this course, but if you want to do some other investigating or research on your own and to see what else is out there, you'll find that this Euler phi function does come up quite a bit. And if you go on to take higher level math courses like abstract algebra, you'll be seeing that guy. If you haven't already, you'll be seeing that guy show up in there as well. But here's the statement of Euler's theorem. So you have some number a being raised to typically some power is congruent to what mod n? Well, if a and n are relatively prime and n is greater than or equal to 1, which is always going to be the case, so the main prerequisite here, the main thing you have to check is that are a and n relatively prime, then a to the power of phi of n is congruent to 1 mod n. Now, this is not necessarily a result that you have to use, but you may find that it may make your life easier when trying to solve a linear congruence. You could still certainly use any of the previous techniques and methods that you learned earlier on in the course. This is just one more tool that I am offering you to maybe make your life a little bit easier. But the main thing you have to check before you just jump in and use it is, are your a and your n value relatively prime? If they are, then go ahead, use it. If they're not, then you cannot use this theorem. So here's how we would use this in a sample problem here. We're going to find what 3 to the power 365 is mod 70. What is that thing congruent to? Well, a value is 3, n value is 70. Those things are relatively prime because 3 is not a factor of 70. So we can use this theorem if we want. So first I'm going to figure out what phi of 70 is. And in the previous video, we saw what is phi of n if n is just some prime raised to some power. And then also we learned that phi is a multiplicative function. So using the combination of those two guys, we can figure out what phi of 70 is. 70 is 2 times 5 times 7. So we can find phi of 2, phi of 5, and phi of 7 on their own, and we can multiply those results together. And when you do that, you get 24. So phi of 70 is 24. So I know by this theorem that we are introducing in this video, by Euler's theorem, 3 to the power 24 is congruent to 1 mod 70. Now, I want to take that 3 to the power 365, and I want to get a 3 to the 24 showing up in there somehow. So I'm going to do a little bit of work with the exponent there, and thus also our base. 3 to the power 365 is equal to 3 to the 5th times 3 to the 360. I'm breaking it down into the product of two things that have the same base. We're sort of working in the opposite way that we typically would if we were working with exponents that have the same base. Here we're breaking up powers, we're separating powers instead of adding them and turning two terms into one. But I purposely broke it up into the 3 to the 5th and the 3 to the 360 because I can nicely pull 24s out of 360. 360 is equal to 24 times 15. So this right here is 3 to the 5th times 3 to the 24th raised to the 15th power. So when we take this guy, when we take the congruence of this guy mod 70, I can replace that guy there with a nice simple 1. So 3 to the 365th is just congruent to 3 to the 5th times 1 to the 15th mod 70. Obviously 1 to the 15th is 1. 3 to the 5th is 243. And it's really nice and easy to take 243 mod 70 and you get 33. So once again, this is not a theorem that you necessarily have to use, but you may find it very helpful to use based on your A value and your N value, as well as what your power is. So this is all I wanted to mention as far as Euler's theorem. Just a nice short video just telling us what the theorem is and how we can use this to find congruences. If you have any questions or comments, be sure to drop them in the comment section below. Otherwise, take it easy, guys.